Sure.
No. Welcome to the new class. Welcome and welcome and welcome. Welcome to the new class. Okay, welcome to this class. In this live training class, we shall discuss electrical energy and electrical power. Electrical energy and electrical power. That's what we shall discuss in this video. And we shall look at a device called fuse. Then we shall still talk on factors affecting sensitivity of voltmeter and ammeter. Those are the things we shall discuss in the next 45 minutes, because I believe that this class must not take more than 45 minutes. Okay, class. Let us continue. Let us start. Electrical energy and power. Electrical energy and power. What is electrical energy? What is electrical energy? What is electrical energy? Electrical energy is what energy used or dissipated when a current flows through a circuit. Write it down. The energy used or dissipated. Electrical energy. This is the energy used. This is the energy used or dissipated when electric current flows through a circuit. Please write it down. The energy used or dissipated when electric current flows through a circuit. Take note of that. Please take note of that. The energy used or dissipated when electric current flows through a circuit. For example, when you have a bulb, the energy used in the bulb when electric current flows through it is known as what? Electrical energy. When you have a bulb and you on your bulb, when current flows through that bulb, the energy that is used by that bulb to produce light energy is known as electrical what? Energy. For example, when you on your what? Your pressing iron. The energy used by that pressing iron when current flows through it to bring out what? Its energy is what? Electrical energy. That's why they say electrical energy is energy used or dissipated when electrical current flows through a circuit. The energy used by a bulb to produce light energy when a current passes it is known as what? Electrical energy. And electrical energy, it is measured, write it down. It is measured in joules. It is measured in joules. Electrical energy is measured in joules. Please take note. What is commercial unit of electrical energy? Like you have your NEPA, your PHCL. They sell it to us. They sell energy to us. We pay for the energy that we use. What is commercial unit of electrical energy? The commercial unit, write it down because it's there in your past question. The commercial unit of electrical energy. This is the unit of electrical energy, joules. Then the commercial unit of electrical energy. The commercial unit of electrical energy is kilowatt hour. Write it down. Kilowatt hour. That is kilo. W means what? Watt hour. Then H means hour. Kilowatt hour. The commercial unit of electrical energy is kilowatt hour. Take note of that. The commercial unit of electrical energy is of kilowatt hour. And take note, 1 kilowatt hour is equivalent to 3.6 times 10 raised to the power 6 joules. Write it down. It's coming in your question. It's coming out in JAMB. Take note. The unit of electrical energy is joules. Then we have commercial unit of energy, electrical energy. Like NEPA now, they are into commercial aspect. They are selling electrical energy to the world consumer. Then in what way do they measure it? The commercial unit of that electrical energy is 1 kilowatt hour. Take note. Then 1 kilowatt hour is what? 3.6 times 10 raised to the power 6 joules. Write it down. 1 kilowatt hour is 3.6 times 10 raised to the power 6 joules. Then let's look at what is electrical energy. I can also simply say electrical energy is the product of potential difference. The product of potential difference and quantity of charge. Q. Electrical energy is the product of potential difference and quantity of charge. That means from here, if I change this to mathematical expression, I will have electrical energy E equal to what? Q. That means quantity of charge multiplied by what? Potential difference. Where E is electrical energy. V is potential difference. And you know that the unit of potential difference is what? Volts. Electrical energy, I told you, is what? Joules. The commercial unit is what? Kilowatt hour. Take note of that. Then Q is what? Quantity of charge. quantity of charge. And the unit of quantity of charge is what? Coulomb. Take note of that. Take note of that. Take note of that. Take note of that. Then from here, from current, since I know that quantity of charge equal to current times time. Don't forget, what is current? Current is the rate of flow of what? Charge. When you have current, which is what? Rate of flow of charge. Current is what? Equal to quantity of charge over time. I've taught you that in the physical class. Those that attend my physical class. Current is equal to quantity of charge over what? Time. If I make quantity of charge the subject of the formula, and we have quantity of charge equal to current times time. That means anywhere I see quantity of charge here, I will change it to what? Current times time. And we have electrical energy. This Q we change to IT. That means ITV. Take note of that. Let me call this one equation 1. Let me call this one equation 2. That means ITV, or I can say VIT. VIT. Take note of that. Let me VQ here. That one is better so that it will be easy. Electrical energy is the product of what? Potential difference and quantity of charge. The product of potential difference and quantity of charge. Potential difference and charge, or charge and potential difference. Don't forget, multiplication is for commutative. Don't forget. Then from here, I have Q equal to what? IT. That means whenever I see Q, I change to what? IT. I have electrical energy equal to what? VIT. Where I is the current. I is the current measured in what? Ampere. YT is what? Time. Measured in what? Seconds. Measured in seconds. Please take note. Right there. Write that down. Then we call this one equation what? 2. Equation 2. Take note of those formulas because we are going to use them in solving question. Please take note of that. Then don't forget, from Ohm's law, since V equal to IR from Ohm's law, since potential difference equal to current times what? Resistance. Since V equal to IR, anywhere I see V, I change it to what? IR. Anywhere I see V, I change it to what? IR. And we have electrical energy equal to what? This V we change to what? IR. Don't forget I have IT times IT. Then from here we have electrical energy equal to I times I squared. Then RT. Take note of this. Take note of this formula. This formula. Take note. This third formula is known as what? Joule's law of heating. I will still give you Joule's law of heating. Formula is there in your past question. It came out 1992 JAMB, 1978 JAMB, 1981 JAMB, 1923 JAMB, 1924 2023 JAMB, 2024 UTME. Take note. This particular formula is known as what? Joule's law of heating. I will still explain. Write it down. Please write it down. Please write it down. That means how many formula for electrical energy have we gotten? We have E equal to VQ. We have electrical energy equal to VIT. When you remember Victoria Island times time. Electrical energy is for VIT. Then we have electrical energy equal to I square RT. I square RT. Take note of that. Take note of that. Take note of that. Then another one. You know that from Ohm's law, I said V equal to IR. If I make I subject of the formula, graph of what? Power. Electrical power equal to what? Electrical energy over T. Then I'll just integrate. I'll get this formula. Take note of that. But we don't need that now. We don't need that. This is just JAMB. Simple JAMB. Simple JAMB. Please write them down. Write those down. Write them down. Write them down. Oh, there's no problem. Technical, no problem. Okay. Write them down. Write them down. Please take note the first formula. Electrical energy equal to what? VQ. That is product of potential difference times what? Of charge. From here, Q equal to IT. Change Q. We have this. Then V equal to IR from Ohm's law. From Ohm's law. V equal to IR from Ohm's law. Anywhere I see V, I change it to what? IR. I have this. And I told you this formula is known as Joule's law of heating. Joule's law of heating. V over R. When R is ratio of V to R. Anywhere I see I change to V over R. Elsewhere, I have this. Take note of that. Take note of that. Let's move to electrical power. Let's move to electrical power. Let me write it here. Electrical power. Electrical power. Electrical power. This is the rate. This is the rate at which electrical energy is used or dissipated in a circuit. Write it down. This is the rate at which electrical energy is used or dissipated in a circuit. Write it down. The rate at which electrical energy is used or dissipated in a circuit. That is electrical power. The rate at which electrical energy is used or dissipated in a circuit. Write it down. Write it down. Please write it down. Please write it down. And don't forget the unit of electrical power. The unit of electrical power is watts. 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 The unit of electrical power is watts. Don't forget, I told you that the unit of electrical energy is what? Joules. The commercial unit of electrical energy is kilowatt hour. It's there in your past question and it's coming out this year also. The commercial unit of electrical energy is kilowatt hour. And you should know this. 1 kilowatt hour is equivalent to what? 3.6 times 10 raised to the power 6 joules. Take note, JAMB student. They will ask you. Because that is what they ask now. Even there was a question I saw last year. They asked, what is the value of velocity of light? Velocity of light in air. That is 3 times 10 raised to the power 8 meters per second. They will ask you this. That 1 kilowatt hour is what in joules? 3.6 times 10 raised to the power 6 joules. Take note. Take note. If you convert it, 3.6 kilo means 1,000. Then R, please convert R to what? Seconds. That means times 60 times 60. When you do your mathematics, you have what? 3.6. That means 1,000 times 60 times 60. 3.6 times 10 raised to the power what? 6 joules. If you do your calculation, please take note. Please take note. 1 kilowatt hour equal to 3.6 times 10 raised to the power 6 joules. Kilo means 1,000. Hour, convert hours to seconds. That means 60 times 60. Take note of that. Take note of that. Because they will ask you. Please, write it down. Please, write it down. Write it down. Write it down. Let me know this. Class. So interesting. That means I can simply say electrical power is what? The rate at which electrical energy is used or dissipated. The rate at which electrical energy is used or dissipated. And I told you in physics or chemistry, whenever you hear the word rate, Rate. That means it has something to do with time. The rate of electrical energy. Electrical energy over what? Time. If I say the rate of charge, that is current. Current is the rate of charge, that is charge over time. Velocity is the rate change of what? Of displacement, that means displacement over time. Acceleration is the rate change of what? Velocity, that means velocity over what? Time. Whenever you hear the word rate, it has something to do with time. This one is the rate at which electrical energy is used. The rate at which electrical energy is used. That means electrical power is electrical energy over time. Take note of this. If I integrate this one, I will get this formula, electrical energy. But don't let us, because for JAMB is just simple enough. The JAMB won't ask for any one of those three. But for those of you writing JUPEB, we have special class for JUPEB. This is just for JAMB, but JUPEB student can still learn from it. We have a special class for JUPEB. And don't forget to subscribe. Press your subscribe button. Please share our video to your friend. Please do that. And if you want to learn any skill, if you want to learn what? Software development, data analysis, UI, UX, cyber security, machine learning, don't forget to contact us. Go to www.neotisa.com. We are building the web app. We are building web app for education. That is EdTech. www.neotisa.com. We are the one building it. We are teacher. We are also what? Our software engineer. Please take note. We are teacher. We are also software engineer, first of its kind. Please, if you want to learn any technical skill, don't forget to contact us. Please, the updated web app will be pushed to the internet, to the line very soon. Will be pushed online very soon. The one you have now is the old version. The updated one will be pushed afterward, JAMB, which we are going to be using to do live classes. Please take note of that. If you want to learn any technical skill, don't forget to contact us. Please. Let's move. Then from here, we have electrical power equal to electrical energy over time. Then since electrical energy equal to VIT, anywhere I see E, if I change it to VIT, I will have electrical power equal to what? VIT over what? Time. T cancel what? T. I will have electrical power equal to VI. That is Victoria Island. Take note of this formula. Take note of this formula. Write it down. Electrical power equal to what? VI. Victoria Island. Write it down. Please write it down. Please write it down. Please write it down. Then let's move. Let's move. Let's move. From here, what we have? From Ohm's law, since V, the same process from Ohm's law, since V equal to IR, same process, since V equal to IR, and we have P equal to V, change it to IR, and we have IR times what? R. V is what? IR, and change the V to IR times R, and we have P equal to I times R, I squared R. Take note of this equation. From here, now you have, since I equal to V over R, the same process, since I equal to V over R. Anywhere I see I will change to V over R. And we have power equal to V over R, all squared times what? This R. Take note of that. Then from here, let's write it here. And we have, from here, and we have power equal to, open the bracket, V squared over R squared times what? R. This is R in two places. One R cancel one R. And we have power equal to what? V squared over R. Take note of this formula. Take note of that formula. Write them down. Please, write them down. Please, write those formula. Write them down. Write them down. That is formula for electrical energy and power. Electrical energy and power. Electrical energy and power. Electrical energy and power. Let me run this one. Oh, 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 oh. Oh, oh, oh. Oh, oh, oh. Class, let me summarize all the formula for electrical energy. For electrical energy, I have E equal to what? QV. E equal to, or let me say VQ. That would be easier for you. Or VQ, they are the same. Don't forget, I told you that multiplication is for commutative. You can say 3 times 4 or 4 times 3. We give you the same. E equal to, I have VIT. I have E equal to what? I square RT. I have E equal to what? V square over R times what? T. I have it. That is electrical energy. For electrical power, if you remove the T, that is electrical power. Just know the formula of electrical energy, then remove the T, that is electrical power. For electrical power, the first formula is what? Electrical energy over time. The second one, power, is what? VI, remove the T. When you know electrical energy, remove the T, that is electrical power. P, electrical power, equal to I square R, remove the T, that means electrical power, equal to I square R. Electrical power, equal to what? V square over R, remove the T, remove time, that is electrical power. Once you know the formula of electrical energy, just remove the T, that is what? Electrical power. Take note of that. And don't forget, I told you the unit of this is what? Joules. While the commercial unit is what? Kilowatt hour. And I told you 1 kilowatt hour equal to 3.6 times 10 raised to the power 6 joules. While the unit of this one is what? Watts. Take note of that. Take note of that. Take note of that. Take note of that. Let us try. Combination of 2 or more lamps in series or parallel. Combination of 2 or more lamps rated in watts. Rated in watts, in series or parallel. When you have 2 or more lamp is L-A-M-P, yes, lamp, Abi, L-A-M-P-S, lamp. 2 or more lamps rated in series or parallel. When you have 2 or more lamp bulb, 2 or more lamp rated in series or parallel. How do you calculate their combination of power? Listen, take note. The total power, write it down, because we are going to use all this to solve questions. They are there in your JAMB. The total power of lamp connected in series or parallel. The total power of lamps connected in series or parallel is what? Power of the first lamp plus power of the second lamp plus power of the third lamp plus power of the n infinity. That means to infinity. Take note. That means if you have 3 lamps connected in series or parallel and they want you to calculate their total power, just add the total power together. Add the total power together. It's a question in 1989. It's there in your past question. We are going to solve question with it. We are going to solve question. That means when you can say 2 lamps of 60 watts are connected in series. What is the total power? How many lamps? 2. Each of them 60 watts. Connected in one series. What is the total power? That is 60 plus 60, which will give you what? 120 watts. When you have lamps connected in series or parallel, if you were asked to calculate the total power, just add their power to them. Take note of this one, because we are still going to use it. Please take note of that. Take note of that. Let's move. Right. Joule's law of heating effect. 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 Joule's law of heating. Write that. It states that the electrical heating or energy, don't forget, electrical energy causes what? Heat. Instead of the electrical heating or electrical energy is directly proportional to the square of current, resistance, and time. Take note of that. It says that the electrical energy is directly proportional to the square of current flowing through an electrical circuit and resistance of the electrical circuit and time. Take note of that. Meaning that electrical energy, that means the electrical heat, is directly proportional to what? I square, directly proportional to resistance, and directly proportional to time. If I separate them, I can say electrical energy is directly proportional to what? Square of current. Electrical energy is directly proportional to what? Resistance. Electrical energy is directly proportional to what? Time. This combination, take note of that. That's what Joule's law of heating states. That electrical energy is directly proportional to a square of current. Square of current. Current is raised to power 2. Electrical energy is directly proportional to square of current. Is directly proportional to resistance and directly proportional to what? Time. Take note of that. Please take note of that. What is a fuse? Let's look at this. Fuse. You have to know the meaning of fuse. And at the same time, I will give you that. Let me take water. Technical clue. How many minutes do I have left? So that I can know. Ten minutes left. Okay, fuse. This is a device. This is a safety device. This is a safety device that is used to protect home appliances from excess current. Take note. from excess current. This is a safety device that is used to protect home appliances from excess current. From excess current. That is a fuse. It's a safety device that is used to protect home appliances from excess current. How does it protect home appliances from excess current? If you look at your home, you will see that you have fuse. The fuse that plug your TV, you plug your radio, you understand? That fuse is a device that is used to protect what? Home appliances from excess current. How does fuse protect home appliances from excess current? If excess current passes through the fuse, passes through the what? Fuse, it will melt. It will melt. If excess current passes through the fuse will what? Break off or melt. That is how it protects what? Home appliances. If we have excess current passing through the fuse, it will melt or break off. That means a fuse must be made of what? Low melting point what? Wire. Write it down. A fuse must be made of a wire. Take note of that. Take note. They will ask you the property we use in making a fuse. The wire that must be used to make a fuse must be of what? Low melting point. That wire must be what? Low melting point. Must have low melting point. Low melting point. That wire must have what? Low melting point. Sometimes the wire must also have high resistivity. High resistivity. High resistivity. High resistivity. High resistivity. Take note of that. But this one is compulsory. The wire must have a low melting point. Low melting point. The wire must have a low melting point. Very low melting point. Because when you have excess current passing through it, the wire will break off or melt so that it will protect home appliances. Take note of that. Fuse rating. If you have fuse rating of 5 ampere on a fuse. When you have fuse rating of 5 ampere on a fuse, any current above 5 ampere passes through that fuse, what will happen? The fuse will melt. It will break off. Take note. If you have fuse rating of 5 ampere, if you have 5 ampere as a fuse rating on a fuse device, if any current above 5 ampere passes through the fuse, what happens to the fuse? It will melt or break off. If you have fuse rating of 10 ampere, if any current above 10 ampere passes through the fuse, what happens to the fuse? The fuse will break off. Because the fuse is made of a low melting point. Take note of that. Take note of that. Take note of that. And take note of it. Note, a fuse is always, or must be connected, is always connected to a live wire. A fuse is connected to a live wire. A fuse is connected to a what? Live wire. A fuse must be connected to a live wire. And let me give you color coding. Color coding of wire. Color coding. Coding of wire. Color coding of wire. Live wire. The color of live wire is what? Red or brown. Live wire take current from the power source. Then we have neutral wire. Neutral wire. Neutral wire is what? Blue or black. Blue or black. Then we have earth. This one prevents what? Protect user from shocking, from being electrocuted. Earth wire prevents what? User from being what? Electrocuted. This one, the color of the wire is what? Green or yellow. Take note. Green or yellow. Don't forget, fuse is connected to a what? Live wire. Take note of that. Take note of that. Please take note of that. Let's quickly talk on what? Buying and selling of electricity. I'll just give you the formula. Buying and selling of electricity. Buying, and because we have 3 minutes left, buying and selling of electricity. Buying and selling. I told you, next class, we are going to solve questions based on the one we did, conversion of galvanometer to voltmeter and ammeter and factors on affecting resistance of wire. We are going to do all the calculations together with this one in the next class. Please take note of that. Buying and selling of electricity. Buying of electricity. Electricity from NEPA. Buying of electricity from NEPA. The formula, just take note of this formula. Cost or price. The cost in which NEPA is selling to you equal to power over 1,000 times what? Time times what? The price they are selling kilowatt hour to you. The cost of running your appliances equal to what? Power over what? 1,000 times time times what? Price. The time must be in hour. You don't need, because commercial unit of energy, electrical energy is for kilowatt hour. The time must be in what? Hour. The time must be in what? Hour. Take note of that. The time must be in what? Hour. What? Take note. The time must be in hour. Okay. In hour. Times what? Price. Take note of that. The cost they are selling it to you. The cost. Take note. Take note of that. Take note of that. Take note of that. That means cost equal to 1 because I was told about the time. Please just give us few time, please. Cost equal to power over 1,000 times time. The time must be in hour times price, kilowatt hour. Because they will sell a particular unit for you at what? Kilowatt hour. Take note of that. Cost equal to power over time. Please, technical to give me just 5 minutes. Power over 1,000 times time, then times price. Please take note of this formula. Take note of this formula, please. Next class, we are going to look at all questions on this in JAMB. Because next time, before we move to another topic in physics, which will be optics of mechanics, circular motion, and simple harmonic motion, before we go into that, we are going to solve questions on this. We are going to solve questions on this before we move further. And let me quickly talk on this. We have sensitivity of ammeter, and sensitivity of voltmeter. Take note, I've given you, but I want to clarify something. Factors affecting sensitivity of ammeter. Take note, the factors affecting sensitivity of ammeter. I told you sensitivity of ammeter is inversely proportional to internal resistance. Take note of that. Internal resistance. Internal resistance is one of the factors that affect sensitivity of ammeter. While this one, sensitivity of voltmeter is directly proportional to internal resistance of the wire. Meaning that this one, if there was low internal resistance, sensitivity of ammeter will be increased. Low internal resistance inversely proportional. If the wire has a low internal resistance, sensitivity of the wire what increases. But this one, high internal resistance, sensitivity of the wire of the voltmeter increases. That means this one, the internal resistance must be high. This one, the internal resistance must be low resistance. This one requires high internal resistance. Because I made a mistake on the last class, which I saw, and I need to correct that. I made a mistake on last class, which I need to correct. Take note, sensitivity of ammeter. That means low internal resistance will bring about what? High sensitivity of ammeter. Is that affect sensitivity and voltmeter? These other factors are the same for two of them. They are the same for two of them. The other of ammeter and voltmeter. For ammeter, we have internal resistance. The internal resistance must be low for you to have high sensitivity of ammeter. For voltmeter, the internal resistance must be high for you to have high sensitivity of voltmeter. Then the other factors, they affect them the same. The other factors affect the two the same. What are the other factors? Two. Number of turns of coil. The number of turns of what? Coil. The number of turns. Number three. That means the number of turns must be what? The number of turns must be high for both of them. Must be high for both of them. For both ammeter and voltmeter, the number of turns must be high. Number three. Magnetic field strength. Magnetic field strength. That means the symbol for magnetic field strength. For both of them, it must be high. Magnetic field strength must be high. Magnetic field strength. Field strength must be high. Must be high for both of them to have high sensitivity. Magnetic field strength must be high for this one to have high sensitivity. Magnetic field strength must be high. Area of coil. Number 4. Area of coil. Area of coil. The area of coil too must be high for both of them. Area of coil must be high. Must be high for both of them. Must be high for both of them. For voltmeter to have high sensitivity and ammeter to have high sensitivity, the area of coil must be high. The magnetic field strength must be high. The number of turns must be high. But the only difference is internal resistance. For this one to have high sensitivity, the internal resistance must be low. For this one to have high sensitivity, the internal resistance must be high. Take note. Factors affecting sensitivity of voltmeter and ammeter. We have internal resistance, number of turns, magnetic field strength, area of coil. But the internal resistance for voltmeter must be high. Internal resistance for ammeter must be low. The other one are the same. Please let us take note of that. At this moment, let us call it a lovely day. In the next class, we shall solve questions on everything we've done. A lot of questions. I remain myself, Jamb from Neotisa. Thank you.